extremely important in terms of connectivity on a global scale. India has multiple landing stations for undersea cables. Those landing stations are manned mainly by the private sector, one or two government landing stations as well. But the biggest problem with undersea cables, as you will very well understand, Navika, and it's not analogous to India alone, but across the world, is really the maintenance of those undersea cables, because they snap all the time. Simple examples where draft levels are low, you don't have deep drafts, fishing nets that cut into cables, marine life that cuts into cables, and therefore repairing those undersea cables is not an easy task. It takes a lot of capex in terms of equipment, setting that up, and therefore maintenance of those undersea cables is also extremely important, and this is a step in that direction.
But we did this in the past. I remember from our times when I covered Telecom, Vajpayee era, we had similar undersea cables with Singtel and from India to Singapore. How are those cables doing, and has that experience taught us how to effectively manage this technology?
So it's not rocket science in terms of undersea cables. What's happened over time is following Moore's law in terms of the number of chips that will increase the capacity of the resistor. Similarly, for undersea cables, the amount of information through that OFC that you can push through. So the same cable width can transmit exponentially greater amount of data bits into the system. And therefore, the large volume of data that comes in, and the key issue is separating domestic traffic from ILD traffic. So that's part one. Part two is that the undersea cables have become many more in number, because connectivity to Africa is separately, connectivity to the Middle East is separate, connectivity to Singapore is separate, connectivity to the rest of ASEAN is separate, and then off to Europe and to the Americas. So the number of cables that are coming in, because the amount of data that's being consumed has also grown tremendously. And with our targets that we are looking at over Bharat 6G, when 6G technology becomes all pervasive, is to ensure 100 Mbps per customer. We're today at 20 Mbps, so we're looking at a jump of 5. We were at 1.5 Mbps 10 years ago. So guaranteeing 100 Mbps per customer, making sure you're able to give 1 petabyte per gram panchayat. And so the amount of data that's going to be consumed is going to be exponentially larger. And so you'll have to have both on a domestic basis and an international basis. And for the international basis, you'll have to have many more undersea cables that are laid.
Mr. Scindia, let me also ask you. A question is often asked.
So for example, and even for the domestic side, so we've laid an undersea cable to connect to the Andamans. We've laid an undersea cable successfully to connect to Lakshadweep. Both have been close to about 1,000 crore projects that were inaugurated by the Prime Minister in late 23, early 24.